In this recording, I'm going to introduce 4-hydroxycyclohexanone, its chemical physical properties, bond types, hybridization, classification, and their associated counts. To begin, the molecular formula of 4-hydroxycyclohexanone is C6H10O2. The carbons can be represented by the vertexes in this ring. The hydrogens pertain to each vertex aside from the one in the ketone, so these are all CH2, 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 a CH group, and then a hydrogen bond of this oxygen, which sums up to 10. The two oxygens can be seen in both functional groups in the molecule as well. There are 2 degrees of unsaturation, and that is represented by the pi bond to oxygen and as well as the aromatic ring itself. The functional groups present are the cyclohexone, the aromatic ring, the ketone, which is distinguished from this carbon double bonded to oxygen with 2 substituent R groups off it, and the alcohol at the 4th position of the ring with an oxygen bonded to a hydrogen. The molecular weight of 4-hydroxycyclohexanone is 114.14 grams per mole. It has a melting point at -1 degree Celsius, a boiling point at 256 degrees Celsius, and its physical state at 25 degrees Celsius is a liquid. I would also like to mention and discuss the IUPAC nomenclature of this molecule. So as we look at the compound, the functional group with the highest priority is going to be the ketone. So therefore the ketone is going to be at the end of the molecule with the suffix -one. And then the aromatic ring is represented by the cyclohex, as it is a cyclohexane. And then the hydroxy group at the 4th position represents the alcohol group. It's prefix for the alcohol group. So 1, 2, 3, 4 at the 4th position. Now to discuss the bond types, there are 18 sigma bonds, and this constitutes all carbon-to-carbon bonds, carbon-to-hydrogen bonds, this oxygen-to-hydrogen bond, as well as part of this carbon-to-oxygen double bond. And then the pi bond is represented by the carbon-oxygen double bond. The hybridization, we can see that there are 5 sp3 hybridized carbons, 1, 2, 3, 4, 5, 1 sp2 represented by the ketone, and no sp3 hybridized carbons. Classifications of each carbon, we can see that there are no CH3 groups, but there are 4 CH2s represented by the sides of the rings, and then a CH group bonded to the alcohol, and then 1 lone carbon group bonded to the ketone. In this recording, I will now show you how to build the physical structure for 4-hydroxycyclohexanone using the Snatoms molecule kit. So to the right, I drew the Lewis structure. To the left, the condensed structure, and in the middle, we will see the molecular formula C6H10O2. So each snatom, each molecule will be associated with its snatom. The hydrogens, 10 hydrogens represented by the white snatom, 6 carbons represented by the black, and oxygens, 2 of them red. And these are our double bond bonding magnets. So to begin, I'd like to mention that we have 3 functional groups present. We can see from these 3 carbons, the middle one bonded to this oxygen, double bonded to this oxygen, represent the ketone functional group. This OH group bonded at the 4th position of the ring represents the alcohol group, and then this carbon ring represents an aromatic ring. So again, I'd like to also talk about the IUPAC nomenclature in this molecule. So we can see that the priority functional group is the ketone, so the prefix -one will be placed at the end of the molecule. The cyclohex represents the cyclic hexane, or cyclohexane, the aromatic ring, and then the hydroxy group, the prefix, is labeled for the alcohol at the 4th position of the aromatic ring. So I'd also like to mention that when looking at the physical structure of these snatoms themselves, we see that there's bonding points on each snatom that represent the number of valence electrons that each atom has originally. So carbon is going to have 4 valence electrons in its shell. Oxygen is going to have 6, but we'll only be able to bond, make 2 bonds to reach its full 8 valence electron cap. And that represents the octet rule that every atom aside from hydrogen is trying to achieve, trying to form a full valence shell to make it more stable. So to begin building the physical structure, we will build the ring. And we'll add our hydrogens at the start. The 1st position does not contain any hydrogens. So we will go ahead and designate all our CH2 groups. And then the carbon bonded to the alcohol group only contains 1 hydrogen. And then we'll build our alcohol group. with the oxygen bonded to the hydrogen. And then our double bond to oxygen representing our ketone functional group. And here's the final structure for 4-hydroxycyclohexanone. Again, this represents our alcohol, this carbon bonded to these two carbons, and this double bond to oxygen represent the ketone functional group. And this overall cyclic aromatic ring represents the aromatic ring functional group. And that is how to build the physical structure for 4-hydroxycyclohexanone.